Gas, volume, and pressure are all related through direct and inverse relationships. Volume and pressure have an inverse relationship, which means that when volume goes up, pressure goes down, and vice versa. When the volume is small, the particles will collide with the walls more often because there's less surface area or space to hit them. Yet when it's big, they have more space to move around and will hit the walls less often, and that will lead to a smaller pressure. It can be mathematically represented as this equation. A gas occupies 16,000 milliliters at 1 atm. If the pressure is raised to 800 kilopascals, what is the new volume? You can start by filling in the information that you already know. So far we know P1, V1, and P2. It is important to have all the pressures in the same unit. In this case, I changed kilopascals to atm. I simplified the equation to get volume alone and ended up with 2,030 milliliters. Pressure increased from 1 atm to 7.90 atm. Yet on the other hand, volume decreased from 16,000 to 2,030. This makes sense because of the inverse relationship. Volume and temperature have a direct relationship, which means as volume increases, so does temperature, and as volume decreases, temperature decreases as well. When the temperatures increase, the molecules will be moving faster because they have a higher average kinetic energy. By moving faster, this means they're going to expand, which will increase the volume. When the temperature is decreased, that means that the particles are going to be moving slower because they have a lower average kinetic energy. This means that they're not going to be going as far, which will decrease the volume. The relationship between volume and temperature is known as Charles' law. This can be seen as V1 over T1 equals V2 over T2. A gas at constant pressure occupies 9.20 liters at 21 degrees Celsius. What will its volume be at 45 degrees Celsius? It is important to calculate the temperature in degrees Kelvin. These are the temperatures converted to Kelvin. I then plugged in the values for the Charles' law equation. To make it easier to do out, you can multiply it through a butterfly way, which would be multiplying these two values by these two values. When simplified, the answer is 9.95 liters. In this problem, temperature increased from 21 to 45 degrees Celsius. Then the pressure increased from 9.20 to 9.95 liters. This makes sense because of the direct relationship between volume and temperature. Temperature and pressure also have a direct relationship. When it's hot, the temperature increases, which also increases the average kinetic energy of the molecules. This means that they're going to be moving faster and hitting the walls more often, which increases the pressure of a system. When the temperature is decreased, the average kinetic energy of molecules is lower, which means they're going to be moving slower and hitting the walls less often. This decreases the pressure. The relationship between temperature and pressure is known as Gay-Lussac's law. This can be seen as P1 over T1 equals P2 over V2. A gas in a container has a pressure of 146 kilopascals at 300 degrees Kelvin. What is the new pressure when the temp is raised to 375 Kelvin? First, I can plug in the values for the equation. Next, I'm going to do the same butterfly strategy as I did in the last question. This is what I get when I multiply it out. If I divide by 300, I get an answer of 183 kilopascals. In this scenario, the temperature increased from 300 degrees Kelvin to 375 degrees Kelvin. And the pressure also increased from 146 to 183 kilopascals. This makes sense because of their direct relationship. As pressure increases, temperature increases as well. As a recap, volume and pressure demonstrate Boyle's law, which is P1 V1 equals P2 V2. Volume and temperature demonstrate Charles' law, which is V1 over T1 equals V2 over T2. And lastly, temperature and pressure is Gay-Lussac's law, which would be P1 over T1 equals P2 over T2. In conclusion, volume, pressure, and temperature of a gas are related and can be demonstrated through laws and mathematical equations.